Significance test for regression slope. This section shows how to conduct significance tests and compute confidence intervals for the regression slope and Pearson's correlation. Although no assumptions were needed to determine the best fitting straight line, assumptions are made in the calculation of inferential statistics. Naturally, these assumptions refer to the population and not the sample. We will now discuss each of these assumptions. The first assumption is that the relationship between the two variables is linear. If the relationship between x and y is not linear, a different shaped function could fit the data better. The second assumption is homoscedasticity. This means that the variance around the regression line is the same for all values of x. The clear violation of this assumption is shown in this figure. Notice that the predictions for students with high school GPA is very good, whereas the predictions for the students with a low high school GPA is not very good. In other words, the points for students with high school GPA are close to the regression line, whereas the points for students with low high school GPAs are not. The third assumption is that the errors of prediction are normally distributed. This means that the distributions of deviations from the regression line are normally distributed. It does not mean that x or y is normally distributed. Recall that the general formula for a t-test is the calculated statistics minus the hypothesized value of the statistic divided by the estimated standard error of the statistic. As applied here, the statistic is the sample value of the slope, b, and the hypothesized value is 0. There are n minus 2 degrees of freedom for this test, where n is the number of pairs of scores. Here are the formulas to calculate the estimated standard error of b. The standard error of b is computed by dividing the standard error of the estimate by the square root of the sum of squares, x. The sum of squares x is the sum of the square deviations of x from the mean of x. The method for computing a confidence interval for the population slope is very similar to methods for computing other confidence intervals. For the 95% confidence interval, the lower limit equals b minus t times the standard error of b, whereas the upper limit equals b plus t times the standard error of b. The notation t sub 0.95 is the value of t to use for the 95% confidence interval. The values of t to be used in the confidence interval can be looked up in a table of the t distribution. A small version of a t-table is shown here. The first column, df, stands for degrees of freedom. The second column contains the t-values for 95% confidence intervals, and the third column contains the t-values for 99% confidence intervals. You can also use the inverse t-distribution calculator to find the t-values to use in confidence interval.